Elon Musk said, well, 2% of the lithium-ion battery's mass is lithium, so it's just like table salt in the salad. It is essential, but only in tiny amounts. The major metals in a battery are copper, aluminium, and nickel. But even though lithium plays a minor role for lithium-ion batteries, it's critical to understand its environmental impacts. Many different modeling approaches find that the lithium demand will increase due to e-mobility, and therefore environmental impacts related to lithium are very likely to increase as well. Lithium mining is linked with a high water consumption, affecting fragile ecosystems in arid areas, but also with a high energy demand, releasing greenhouse gas emissions. To understand how we are able to reduce these impacts, we need to quantify them. And this is exactly what I'm doing in my dissertation. I'm Vanessa, and I'm a PhD student in the Ecological Systems Design group. In this project, we quantify environmental impacts, investigate their causes, and we also look into how impacts differ from one lithium mine to the other. So when considering lithium mining, salt lakes are one major source for lithium around the globe. Salar de Atacama in Chile is one of the most famous lithium mines. Beside Salar de Atacama, other salt lakes where lithium is extracted from are located in Argentina, the US, and China. However, the processes involved in lithium extraction vary among these sites. We identify the most important processes for each site and then quantify what kind of inputs, for example, heat, electricity, chemicals, and water are required. We convert this material and energy demand into environmental impacts. For instance, we find that the climate change impacts in general come from energy which is based on fossil fuels, and secondly, from the energy-intensive production of chemicals which are required to extract lithium. When we look at lithium mined from multiple salt lakes, we also find that environmental impacts significantly differ. The reason for this is that the chemical composition of each salt lake is unique, and this means that the production steps and therefore energy, water, and chemical demand vary as well. And this, in the end, is then reflected in these environmental impacts. So, Elon Musk said, lithium in a battery is only like salt in the salad. However, from an environmental perspective, it does not mean that we can ignore it. The salt in the salad might actually be responsible for negative impacts. For lithium, we have the opportunity to react early and tackle the environmental problems at the root, because the production volumes are rather low compared to the expected demand.